Hi, today we'll be doing my presentation on Module 5, Chapter 7, Decimals, Real Number, and Proportional Reasoning. Okay, it's okay. So, our first question, we'll have to turn these decimals into fractions and then find the denominator, denominator prime factors. So, to do this, we'll have to find our place value. This is 10, this is hundreds, and this is thousands. So we'll put our number over the thousand place because 225 over the numerator and 1000 over in the denominator because it is our number over our denominator, which is 1000. This is a simple way to put it. This is a 2, this is 10, plus 2 is 100, and 5 is 1000. So our 1000 will be our denominator, and then we'll have the 225 in the numerator. Now, what we'll have to do, our next step is we have to simplify this since it's a big number. So what we'll do is we'll find out what is the biggest number that will go into both of these numbers, and that number is 25. So it'll be 225 divided by 25, and then 1000 divided by 25, which will give us 9 over 40. So our greatest common multiple is 25, and our number is 9 over 40. Now we have to use this one. So if we have a 0, 3, and a 6, 0 in the tens, 3 in the hundreds, and 6 in the thousands. So again, our denominator is 1000 since we had to move our decimal over to the thousands place at the thousands place. So it'll actually be 36 over 1000. And now we have to find out what greatest number going to both of these. That number is 4, so it'll be 36 divided by 4 and 1000 divided by 4. This will give us 9 over 250. So our new number will be 9 over 250. Now for the second part of our question is we have to put our denominator into prime factors. So here go our little prime factors again. So we have 1000. Now the best way is to do it by 10 since we know tens go into thousands. So it'll be a 10 and 100. Let's do a 10 first. 10, what is our two prime factors that will go into 10? We have a 2 and a 5. That will both give us 10. So this will be, we're done with this side. Let's go to the 100. We'll have 100. 100 could be into 2 tens. 2 tens is not a prime factor, so that will break down to 2 and 5s again. So now that we have our numbers, we'll have 3 2s and 3 5s. Let's go to our next question. Our next question, we had to make a graph. We had to also know what an x and a y-axis is, and we had to find problems that will match the graph. So the first problem is Jane promised his brother that he would spend the same amount of time on the new computer, 50-50. How much time would each spend on the computer? So we know that if one have 2 hours, one will have 1 hour because that is divided by 2. So 50-50 is divided by 2. So if one have 2 hours, they'll both spend an hour each. If they have 3 hours, they'll both spend 1.5 hours each, and so on. And this is our corresponding graph with it. It'll be best to move this down here. Okay, next we have James decide to share half his pens with his brothers. I don't know why I did pens. Show a graph that represents this. So he'll share half his pens. We'll have to see how many pens he'll have left. So to do this, we'll have pens. So we'll have, if he have 2 pens, he'll have 1 left. If he have 3 pens, he'll have 1.5 left, and so on. And this graph will actually be decreasing because he actually subtracting from his pens. And this is our corresponding graph. Now, we have 10 bubble gum balls go into one container. The y-axis equals how many containers, while the x-axis equals how many number of gum balls in the container. So we have x equals how many containers times 10. So we have one container, we'll have 10. If we have two containers, we'll have 20, and so on. And here go our corresponding graph. We have one container, 10, 2, 20, and so on. Now let's go to the last part. So I decided that she would she would square the amount of gum balls given to her, so she'll learn her square roots. The y-axis equals how many gum balls given to her, and the x-axis equals how many numbers that is given to her, then squaring it. So we'll square the numbers. So if she is given 2 gum balls, she will have 4. If she had given 3, she'll have 9, because squaring root is the numbers times itself. And here go our corresponding graph. Let's go to the next one. Next, we'll have to find the percentage of the fraction of each picture. So we'll get these 3 pictures right here, and we have to find out how many is shaded. Now, to start this problem, we'll have to find out how many is shaded. But the thing is, they're not equal. So to start out the problem, we'll have to divide it into equal parts. And when we divide it like this, we have equal parts. Now we have how many parts, which is 8, and we have 1 shaded. Now we number them, and we have 1 out of 8, and that is our factor. The top is the numerator, and the 8 is the denominator. The numerator is how many is shaded will go into the top, and how many in total will go into the bottom, and in the bottom, the denominator. Now we have to also, since we have a fraction, we have to give it into a percentage sign. So to do this, you'll divide the numerator by the denominator, and this will give us 0.125. Now to do this, to get the percentage, you'll just move the decimal over 2 places, which will give us 12.5%. Let's go to the next one. Again, this one is not divided equals again, so we'll have to just divide it equally, and then number how many we have. In total, we have 18, and we have 7 shaded. So how many shaded will go on top, and total is on the bottom, which is numerator, denominator. Now we need to put the fraction into a decimal because it's easier that way. So we'll have 7 divided by 18, which will give us 0.389 or 0.39 if we round it. So so this is 38.9% in total. Now to our next one. We have this simple shape. So this is actually equal, so we don't have to divide it. So we have 2 sections. We only have 1 shaded, so it'll be 1 over 2. Now we divide the 1 by 2, and then this will give us 0.50, which is 50%. Let's go to the next problem. The next problem is we have these many shapes, and we're trying to fit them into the hexagon. So what we have to do is we have to see how many times the shape will go into the hexagon, and then we'll find a percentage, and they give us the percentages. So what we have to do is assign these percentages to the shape. Okay? So I have our percentages right here, and then our shapes. Now, we have a triangle. A triangle will be able to fit into this 6 times if we actually go through here, and then we'll have 6 of them. So our section will be 1 over 6, which is equals to 16.67%, which will go to this one. Now we have this one, which is a little diamond. So our diamond will be able to fit into this 5 times if we just keep going. So it'll be 1 over 5, which is 19.2. Now we have our rhombus. our rhombus will be able to fit in here 3 times. So it'll be 1 divided by 3, which is 33.3. Now our square is a little tricky because it'll be able to fit, but it'll be able to fit a few times. So but it'll have a decimal time because it'll only be able to fit, it will not quite 2 times, but not 3 either. So it'll be in the middle. So it's hard to have the fraction. But we know that the rhombus and square is right close to it. So we know that 38.5 will go into the square. And now we have our last shape, which will take up half of our hexagon. So it'll be 1/2, which is 50%. Okay. Now for our fifth question, sorry. Now we'll have to find the percentages of these problems given to us. Now I decided to use quarters because it's like money and it'll be easier to understand. So I use quarters. So it'll be easier to everybody to be able to understand. Now our first one, given A and B, what percentage of P equals B is A? Okay, that's a tongue twister. So I got a little section right here, a little problem, so it'll be easier to understand. Kate has 4 quarters. She decided to give 2 to her sister. What percent of quarters Kate give to her sister? Like I said, it will be easier to use money because most people know quarters equals 1 whole. So I use quarters instead. So she has 4. She gives 2 to her sister, which means she takes 2 from her and she gives 2 to her sister. Now that we know she gave half of them to her sister. So it will be 50, she has 50% left. And she gave her sister 50%. Now we have find the part. Given the percent P and the whole B, what is if it is P% of B? That's also a little confusing. So I have a problem right here. Kate has 4 quarters. Her sister asked for 75% of her quarters. How many quarters is Kate's sister asking for? So she has 4 quarters. Here we go. And she said 75%. Now, like I said, it's easier to use money because we know that, I was trying to just move it. Now we know that 75% is 3 quarters, which means 3 of her quarters will go to her sister. So how many is her sister asking for? Her sister is asking for, sorry, I don't know how the quarters disappeared. Her sister is asking for 3 quarters. Okay, now we have our next and last problem. Okay. Find the whole given a part of A that is P% of the whole B. What is the whole B? Okay, again, confusing, so here's a problem to say it. Kate has received 1 quarter or 25% of Kate quarters. How many quarters did Kate start with? Now this is Kate. So she has 25%, which is 1 quarter. How many quarters did Kate start in the first place? So she has 25%, which was the one that she gave, so she'll have 25%. Now we add another 25%, which will give us 50%. We add another 25%, which will give us 75%. And then we add another quarter, which will give us 100. So in total, she'll have equal 100, which is 4 quarters, which means Kate started with 4 quarters. Now, our last problem. Create a proportional reasoning scenario, then create a table and graph to show the rate. I don't know why I'm moving this. The rate of the proportional change. So, again, that's a little confusing. So I got another problem. Mary walked 1 mile in 5 minutes. How long will it take for her to walk 6 miles? So it'll be easier because we know 1 mile is 5. So if she's keeping a constant rate, which is 5 minutes, so she'll have 1 mile for 5 minutes. So 2 miles at another 5 minutes, which will give us 10. And then 3 miles will give us 15, add another 5, and then so on. So we'll have to keep 20, 25, 30. Now we have to make a chart. So we'll have miles as our x and minutes as our y. And this is the constant rate that she'll be have. So we also know if she keeps walking, her seventh will be 35, and it'll just keep going until she gets tired, apparently. And that will wrap up our module 5. Thank you for watching.